comes from RedHat, and it's going to be about cloud technologies, about automation in DevOps. And now, please welcome Senior Technical Marketing Manager, Mr. Siamak Sadeghianfar. Was it correct?
Yeah.
Welcome on stage. Applause.
Hi everyone, I'm Siamak, RedHat, and I work a lot with a product was called OpenShift. It's a container management platform. I'll talk about that, talk about DevOps, automation, and I assume you've been hearing a lot about DevOps yesterday from different aspects of that. And I'm going to focus a lot on the technology part of automation, so not the others that are involved in that process. Just a quick hands up and just get a feeling though what you guys are familiar with. How many of you have played with Docker before? Well, a lot of hands. How many of you are running them in production? There are a few. Kubernetes, how many of you have heard about Kubernetes? Very known. And OpenShift, anyone familiar with OpenShift? Okay, very well. It's about the same as Kubernetes. So let's get started. First of all, so like I mentioned, I'm going to skip the process. I'm taking up the process and the people part of DevOps. I'm sure other colleagues have been talking a lot about that. I'm going to a lot focus on the automation bit of DevOps. How do we automate things? What can we do to achieve best practices or the values that DevOps promotes, right? And why DevOps promotes these values? Because of the deficiencies that we have had in delivering software. Things have been difficult to deliver. We haven't been able to deliver as often as we want. Deployment has not always been difficult. These are history. And DevOps movement started focusing on certain values, certain practices. And it doesn't exactly say how to do it, but it tells us these are good things to do. Focus on collaboration, do these kind of things. It simplifies how we deliver software. But the how of that is left to each team, each organization to figure out how they have to implement those kind of stuff. I've listed some of those values, go quickly around them so that I'm going to refer to them during the session. Everything as a code or configuration as a code, that's what we hear a lot. And the purpose of that is that you want to have the complete setup of your application. It doesn't matter if that's infrastructure, if it's your load balancer, if it's the firewall setting, whatever that is, you need to treat it as configuration so that it can manage the versions of that. You can check it in some kind of version control, Git or subversion or somewhere. It can always recreate the entire environment from scratch, right? The firewall maybe is the most notorious one. That generally that's not anywhere, right? You see somebody's minor Word document that when you deploy this port also needs to be open. Automate everything. Like automation is a big key in DevOps. You don't want to have any manual tasks. The only manual tasks that are left are generally the approval things. So maybe you have deployed the application in some kind of environment, but you want to sign off. Somebody comes and says, yeah, this deployment now is synced with this marketing activity and this events that we are doing in Helsinki, so now it's time to deploy this. That's the manual task, but no copying files around. No feeding values here or there, not adding the URL in the load balancer. Everything else we want to automate. Tests especially, that's also very important, to be able to automate tests. Generally, we haven't managed, majority of us, to reach 100% test automation, but that's a goal that everybody strives to achieve, right? As much as we can. Continuous integration, continuous delivery. On every check-in, on every change on the configuration or code, we want a series of actions to trigger on that code, and with each action, we want to increase the trust in this change being a good change for going into production. Right? We want this to happen on every single change. Application always releasable, so that at any point that we decide we should be able to release the application into production. It's nothing that we necessarily do, but it's a state of mind. So that when somebody's checking something, you check it in as if it's going into production, right? In the agile days, well, it's still agile days, but this definition of done has been always a big fun story. So when something is done it done, or is it done or done? It's this kind of a counter to that. And when you're checking something that is as many dones as you want to add to it, it is done, right? It should be able to go to production. Monitoring, without monitoring, we're kind of blind. We don't know what's going on with the application. We don't know if it's feeling well or not. And this is at all the levels: infrastructure, application, inside application, metrics around the process, how often things are going wrong, how many of us measure these kind of things. Right? Rapid feedback, when you code something, when you change something, you want to know immediately if something went wrong. In earlier days, many of you, I'm sure, remember if you work in the development part, you develop something, you check in the code, you're done with that user story. A week later, somebody tests something, comes back, oh, by the way, there is a bug here, can you fix it? And you have completely switched context. You're working somewhere else. It's hugely inefficient to go back and figure out, remember what you've been doing to figure out what the problem was. Rebuild versus repair. This comes along with the immutable infrastructure that you might have been hearing about. We want to treat that environment as packages that are already built, ready to be shipped or ready to be deployed. If something goes wrong, generally it's not worth to go figure out what's wrong with this one thing. Let's just dispose it and redeploy this whole thing. Right? It's not worth to treat these things as mutable pets that they have to go take care of them. A lot of times things go wrong because of a hiccup, because of a small problem somewhere that is not worth looking into. If it happens every day on the same component, well, that's a trigger that something is significantly wrong. You got to go look at it. But things that happen a lot less often, generally, it's not worth it. Just throw away and bring this up again. And that hooks back into the automation level of automation that we need to require to have. If it's not easy to do that, then you'll be losing on both ends. And pipelines, that's also it's a very popular part of DevOps. Pipeline is that process of automated steps from the check-in all the way to your target environment. This is generally production or pre-production stage. That every time you check in, that check-in, that change goes through this series of steps in an automated way, and as each step goes forward, you have more trust in this change to be ready for production. If it graduates from this process and everything is green, you should not have any doubts that this is ready for going into production. And we're going to look at some of these topics, how we're going to do that with container. Because in our opinion, and there's quite a consensus in the industry, that container is a huge enabler for DevOps. Right? DevOps is not as new as a lot of people think. Right? DevOps got hyped maybe 2-3 years ago, while the conversation about DevOps has been around since like 2009 or end of 2008. The reason that it didn't take off was that it was difficult or costly, both from money perspective and time, to implement a lot of these practices before the containers day. That time in the last 2-3 days, see, that is synchronized exactly with Docker taking off, with the containers taking off. So that made it a lot cheaper, a lot simpler to implement those practices with the container. And we are true believers of container. We contribute a lot to after Docker as a company itself. RedHat is the biggest contributor to Docker project. And we have brought it into Red Hat Enterprise Linux, Satellite, pretty much every part of Red Hat works. So why did it become so simple? Because first of all, anyone that doesn't know what container is? Just challenge me, yeah? So container is just a piece of process. It's one process, piece of operating system that you seal it, it's completely isolated, and with these two simple commands, you can build one and run one. Things are becoming pretty simple, right? So Docker build the name that you want to give to that container, that image, and it builds it for you. It builds a binary that includes your application. It includes the libraries for your application. If you're working with Java, maybe you put the JDK there. If you're deploying on Tomcat, put Tomcat there. You might put a database there. It becomes one package, one shippable package that it can take it and put it on the next machine. The second command, Docker run, and that name of the container, name of the image, it just starts the container. Super simple, right? It takes care of it assigns the IP to it, it brings it up, assigns memory and everything. So simple it comes up within seconds because it's just one process on the operating system. The same as simple it goes down. So imagine compare the efforts of building a virtual machine with a complete stack of the software that you want to run. Compare that to the first command. And if you want to take that and maybe go run it on Amazon first, suddenly, how much effort that involves compared to container, you get a tarball, just copy a regular copy to the next machine and run the second command. You bring that whole stack up on the second machine. So the simplicity that containers bring for us for delivering some software is significant. That's why we believe in so much in it when we talk about a DevOps process. So how would DevOps look like with considering container? So we will have the Docker, our process, our pipeline. The left icon is the iterative process that we're going to deliver software end to end. We have a change. That change goes through a pipeline, and as a result, we build a container containing everything that the application needs. The OS layer, the operating system layer, the libraries, the configuration for your application, everything that your application needs to run. And that becomes an immutable piece that it can deliver to the next team to run that. Right? And that package would run exactly the same across any footprint. If you want to put it on a bare metal, on virtualized layers, on VMware or somewhere else, OpenStack, on public cloud, doesn't really matter. Right? It's the same type of package, independent of what you're running inside. Right? So that's another huge deal about containers. So inside that, I might be running Java, might be running Node.js. Pretty soon, this year, Microsoft's going to release .NET. They have already released the beta. They're going to release .NET also on Linux, on RHEL. So you will be able to run also .NET application within the same container. The value of that is that the people who are working on the right side, they wouldn't get every time a new set of instruction, a Word document, or in some other format that for this one application, you have to go into the bin folder and start catalina.sh. For this other application, you have to run node and this command. For this third application, you have to do something else. All of that look alike. Inside is different. The packaging is the same. They're shipped the same way. They're run the same way. They're managed the same way. Right? We get true standardization across the entire infrastructure. And that's the true value that containers bring for us. A little more detail, so how would that pipeline look like? We will have a developer working on the source code, working on the configuration. Like I said, everything we treat as configuration. How the container itself should look like, that is also configuration, would live in the source control. Commits the change into the source repository, and then our CI/CD engine kicks off, generally monitors that source repo, takes the change, build the code, run some smoke tests maybe. I have simplified that part. This is representing a sample pipeline. So that CI/CD part might be a lot lengthier. Like you build it, you test it, you break it down, you set up an environment, run a couple of more tests. So all that, let's say, is encapsulated in that. And when you're confident enough that this change is ready, you produce, as a part of the same pipeline, a container image for your application, including the configuration. And from that, you ship that on the target environment. That being your development environment, your dev servers, or test servers, user acceptance testing, and pre-production, and so on. So the process becomes a lot simpler, and what we can produce is not just the application itself, it's a complete unit that we can deliver to an operation team, and they would run it exactly the same way. Right? This is not to say that we need to separate these two, because building this process needs a lot of collaboration from the operation, because container itself, it's a technology that belongs to the operating system. It's quite low level in that sense. So building this process needs a lot of collaboration from both sides, but focusing on the technology, it allows us to just ship the container the same way, regardless of what is it that we're producing on the left side. Building the container itself, how do we build that? For the Docker, we generally use Docker files. It's a text file. Inside that, you describe what packages should be installed. Let's say you're building a Docker image based on RHEL, Red Hat Enterprise Linux. You run some yum installs, you copy you're doing Java, your war file or jar file somewhere, you add the commands. You do all that, and you pretty much have control as a root user on that container. You configure it, and when you run docker build, it builds that container and produces one binary for you. Well, let's look a little closer to the right part. How do we do that part? So I have built my, let's say, Jenkins or Bamboo or anything else, have built the container image for me. How am I going to put that on that target environment that I want to run? This part wouldn't happen magically, right? Somebody got to take care of that part. So that becomes a big question because generally we don't have one host, right? You're going to have a number of hosts in your data center. If you're using Amazon, you're going to have a large number of VMs with different characteristics. And you want to run that container on those places. How do you decide on which machine this should run? Right? Maybe several components. How do we do that? Speaking of several components, that's how real applications look like, right? We generally don't build monoliths anymore. Or when we say monoliths, it might not be like we talk about monoliths in the context of microservices a lot, and we draw it as one big box, but reality is that there are still a couple of components. Our monoliths are still divided maybe to front end and back end, right? There's still a database. There still might be a caching layer. So there are, regardless of how service-oriented we are, we generally deal with several components for any application. It seldom is one piece you deploy and everything is running. There are a couple of more. So when we are packaging as container, we're going to run a couple of Docker builds to build all those pieces. In this example, I have one front end, I have one back end, one database, it's maybe MySQL or something. There's a cache layer, might be InfiniSpan, Hazelcast, something else that you put separately, not embedded. And I might be doing some messaging, asynchronous messaging, ActiveMQ, RabbitMQ, lots of that. I have built my images, the binaries are ready. So far, so good. Now I want to run them. I run them with Docker run. Docker run, name of the container, and some parameters I have to add to the end. What ports do I want to expose on this particular container so that the other containers can talk to it. At the same time, I don't want every container to be able to talk to every container. So I have to link also them together so that the backend can see the database, but the front end shouldn't. Right, so we want to control that. So it's a great part. There's a couple of parameters in the end to run that, right? And that brings the entire application up for me across multiple hosts. But who does this? It's a question. Like, am I gonna go SSH to each machine and run Docker run on every single machine? And how do I decide that where I should run the front end in which of these machines or data centers or parts, which of them should be linked to which port? And let's say one of them dies, one of these front ends. How I'm gonna make sure it comes back up? Who is gonna do that? Right. So there is a whole big topic of orchestrating containers on top of the infrastructure that we haven't covered yet. Right. Building container is fairly simple. Running container also fairly simple. But when I have a lot of them, and a lot is not really a lot, just a handful for normal applications, how am I gonna schedule those ones on top of the infrastructure? How am I gonna define that I don't wanna go 8 times or how many times it is, 7 times, run a command to run the container, right? How I can describe this in a reproducible way that a developer joins the application, joins a team, or a tester wants to set up the environment, can just point them to this thing, and they just set up the entire environment up. I'm going to do that. And that's what we call orchestration around container. It's a huge topic, very hot topic. Container itself, everybody agrees on, right? There is a huge traction in the industry. There is very little that, like majority of people I talk to, they agree that container is the way to build software. That's going to change everything. What is left is the orchestration. That's the topic everybody is working on. And how am I going to orchestrate containers on top of my infrastructure? Because just running the container, that is not enough. We need more than that. We need scheduling. Where should my containers run? right? How am I going to decide that? So if I have those 5 containers, how am I going to decide, should it run on the first host or a second host? Maybe this particular application have special security requirements. How am I going to incorporate that? This piece is a database container. I want this to end up on a host that has higher CPU and memory. How am I going to incorporate that? So scheduling is a big topic of how am I going to feed the requirements that I have for my application as configuration to that orchestration, so that when I distribute this on top of my infrastructure, it distributes the way that I want it. Lifecycle and health. How am I going to make sure that if container dies, the state of the system comes back to what it was? Like somebody got to, first of all, discover that this container has gone down, and then try to bring it up. And also, you should know how to bring this up, right? And container, we're going to run a lot more containers that we're running than in comparison to VMs. If you're doing microservices, for one application, maybe you have 20 of them, 20 containers. If you have 50 applications, multiply that. So it's extremely important to automate this process of recovery from failure for the containers. Discovery is another part. So if I have a front-end container and I'm running because of the huge load that I have, 3 instances of that, one of them dies, I bring a new one up. How do other systems interacting with my application know that suddenly there is a new container out there and they shouldn't talk to the previous one that has died? So somehow containers should get to know each other. They should realize that someone has disappeared and there is a new kid added to that cluster, added to that group of services that are being served. That also needs to be automated to use that. Monitoring to make sure that the container, how they're doing, how much CPU they are consuming, how much memory. Authentication is an important piece. Who can create this container? Who can run them? Who can kill them? Different type of actions that you can do on the containers. To be able to aggregate them, it's the compose that will be able to create a blueprint of the application, right? I want to have one configuration that describes this is how my application looks like. 2 front ends, 2 back end, 1 database, 1 cache, 1 messaging. Just this. Describe this, what ports are between them, and I just point someone to this blueprint and runs the whole application. Scaling is also another part that we want to be able to easily scale up when we have more load, add more containers running the same application, scale down when we don't have that. We want this to happen automatically, right? Scaling with VMs is generally a difficult thing. We have to, because the way we treat virtual machines, so it's not so easy to suddenly spin up a new virtual machine with identical configuration, right? It takes a lot of effort and automation to build that into. It is achievable. A lot of people have done that, but with a lot of tears and blood, as we say in Swedish. With containers, since they're immutable, you just say Docker run a new one is identical to all the other ones. It's very simple to stand up new ones. We just need to connect that to some kind of metric so that this happens automatically. As you have more load, new ones come up. Those are exactly problems that Kubernetes tried to solve. So Kubernetes is an open source platform system for managing lifecycle containers. They help with deployment process and automation around containers. Its project was donated, originally developed by Google and donated to the community. And after that, a lot of vendors, a lot of companies, and individual developers that are contributing. It's a super active project. I think they have, if I remember correctly, 500, 600 commits per week. It's a very high velocity project, and we at RedHat, we collaborate a lot with Google. We're after Google themselves, the second contributor to the platform because of the potential that Kubernetes has. So Kubernetes takes care of that scheduling and orchestration part. So instead of I go on every single image and say, a single host and say, run this container, run that, and run that, I can just describe that whole blueprint and tell Kubernetes run this. And Kubernetes makes sure that requirements that I have is incorporated into this scheduling part and puts them on the correct host with the correct characteristic that I have defined. Kubernetes defines also a set of terminology concepts around building this composition of containers. It's once you read it, it's quite familiar for building applications actually. So container is a container, it's still application package, that's no surprise there. A new abstraction they define as pod. Pod is a group of tightly coupled containers. Not necessarily a couple of them, there might be even just one, but it's an abstraction bigger than container, and you could think of it as a host. So one pod has a unique IP address, it might have storage in it, and it has its own network space, it has its own ports. On that pod, if you run two containers, then those two containers, they're sharing the IP address, they're sharing the storage, they're sharing the port, so they might have port conflicts if they're bound to the same ports. But two pods, they have different IPs, different ports and storage. So two different pods, they both can bind to port 80, no conflicts, even though they're running on the same host. Right? Majority of cases, you would run one container within the same pod. Sometimes it makes sense, very few use cases, but sometimes it makes sense to have more than one. Labels are just key values that you assign to the pods, containers, to the objects, so that you can identify them later, right? So if I'm running a container that is running a database, I probably would assign a label like type must equal database or type MySQL, so that later I can query this through selector, say give me all the containers that type is database and the database type is MySQL. I get a group of containers back with this characteristic. There is controller, and controller is a really interesting part of Kubernetes. Controller's job is that you define a current state of something, and you also define the desired state of something. Controller makes sure that it changes the system so that the desired state becomes the current state. So what does this mean? I have one instance of my front end running, one container. That's the current state. My desired state is that I want to have too much of load. I want 3 instances running. So I just say, describe it. I don't go scale up anything. I just describe that I need 3 instances of this. And a controller that is responsible for scaling says, well, the current state is different from what the user wants. Spins up new containers till the current state matches the desired state. Right? It makes sure that what you describe as your configuration happens in the system. And there are different types of controllers in Kubernetes. There is around deployment, there is around scaling, there are for other things. And service is the last piece I'm going to talk about in Kubernetes. It's a set of pods that work together. Right? So when I say we scale the front end to 3, those 3, you generally hide them behind a service. And that's how discovery works in Kubernetes. So that you don't have to think about which pods are servicing my front end. So I define a service called front end, and the system knows that whenever I go to this front end, it should send the request to one of those containers that are backing this service. Right? The client becomes completely abstracted away from this notion of containers coming up, going down, scaling up, scaling down. The service is always the same. Service is smart, it knows. If a container goes down, it removes that IP from a list of containers that are load balanced. If it comes up, it adds it, right? So it abstracts away these fluctuations that we have in a number of containers. Service gives us a stable front to reaching the containers. So how would that work? You have a master in Kubernetes that is the brain. It does the operation. It starts the containers, does all the stuff that I talk about, does the scheduling. And you have a couple of nodes where the actual containers run. So you, through the API that the master provides, there's a CLI command, there is a web GUI, and so on. You say, this is the description of my application. I have container X. I want 2 instances of that to run, replicas 2. Give 1 CPU core to it and 1 GB of data. And I have another container for this application also that needs to run also in 2 instances with half a core and 2 GB of data. I just described this, pass it to Kubernetes. Kubernetes goes find those containers, looks into nodes, see where it has capacity. It looks into your configuration. If you have said this is high security area, this needs to go onto the development part of my infrastructure. This is staging environment, so whatever characteristic you have described for the scheduling, you can pretty much give tips to Kubernetes how to schedule this kind of things. And it brings those containers up on top of the container, on top of your host, your nodes. It automates this whole thing. If one of them dies, it's still that control that I mentioned. So I have described here that container X needs to have 2 instances. That's the current state. One of them dies. So the current state becomes different from desired state, right? Desired state means 2 instances of this container. The current state becomes 1. So the controller that I talked about, it simply kicks in, realize that there's a difference, bring one container up so that those states match again, right? So it has, we call it self-healing. It's if something died, it makes sure that it brings the system back to the desired state again. How does that spec look like in like the real spec? So the left part is that blueprint that I mentioned, describing how a container should run. So it's called, you can describe it as a YAML or JSON, and we call this type deployment on the left side. The name of it is front end for this particular container. I'm saying which container image should run. It's in the lower part. Some limits, how much CPU, how much memory. I don't have to give it. It can always go with default. In this example, I want to say only use 100 millicores of CPU and 100 megabyte of memory so that the platform balances the container. The container doesn't swallow all the resources available on the host. And I'm saying run 3 instances of this through replicas. Fifth line. On the right side, I'm defining the service, that grouping of containers. So I'm defining a service in front of these 3 containers, who, if somebody needs to go to this front end, all they do is they just go to port 80 of service front end. And that service is smart, it's gonna figure out those containers that are backing this service, right? That's how discovery works. How are these 2 connected? You might be thinking about it. It's connected through the selector. So under the port, you say selector app is Facebook tier frontend. Those are arbitrary key values. So the service is going to look into all containers, any container that it finds that are labeled with those 2 key values, it would redirect the request to those ones. So discovery works through the labels. So I define a service. I say this service is backed by with any container that has these labels. A request comes to the service, the request is sent to one of the containers that have that label. So what does Kubernetes does like to summarize? It does the scheduling to describe your application, the complete composition of your application, and the scheduling on top of the infrastructure that you have. It manages the health of the container. If one of them dies, it brings it up. It also checks even for applications. You might be running a Java application and you say, well, Kubernetes wouldn't know what it means for my application to feel healthy. You can expose a URL, and Kubernetes will call that URL whenever you say your application feels fine, then it will think it's fine. So the container might be up and running, but you in your application don't think that your application is healthy. Returning the correct error code, then it makes the Kubernetes to restart or create a new container. Takes care of discovery through services, it monitors the containers, it brings authentication, so it gives access control of who can run this container, what the containers can run, because generally containers run as with root access on the host, so it can do really bad stuff on the host. Through Kubernetes, you limit that to a certain scale, and it brings also persistence, so you can have persistent storage within the container, and when the container dies and a new one comes up, you still have the exact same storage available into your container, right? That's really good for stateful applications. A lot of container-based solutions, they say you have to be stateless. You have to do 12-factor apps, but it's not necessarily true. Through persistent storage in container, you can always bring back the same storage. So it might be a MySQL database, the container dies, you bring a new container up, and you have the exact same storage available to you, so nothing bad really has happened. Your application can connect and consume the same type of data. So in that previous slide that we had, Kubernetes would take care of that scheduling. You describe those number of containers that you have, and Kubernetes is going to look into your environment, see where you have capacity, and distribute them in the way that you want to manage that infrastructure, right? So bring it back into the pipeline. So we have the developer checking in, the configuration, that blueprint, those YAML files that I mentioned into the source code. Jenkins picks it up, builds the containers, triggers Kubernetes through the API that can you schedule this kind of thing, and Kubernetes take care of putting them on the infrastructure, right? Regardless of what kind of infrastructure you have. So that goes without saying, virtual, physical, cloud. But there is still a few more pieces that are simplified here, right? Yeah, let me get to one thing before. So Kubernetes itself, so why Kubernetes? Why Red Hat chose Kubernetes? Because we work with standards, right? We're true believers of standards. Standard enables users not to be locked into a particular technology. And something standard means there is backing from the industry, backing from many projects, many products. So if you use one, you can easily go to another one if your requirement needs you to. If your requirements wants you to go to something else. And that's what we see is happening in Kubernetes. So there's a lot of backing in the industry. A lot of people contribute to it, and we already see there are a lot of products that are based on it. OpenShift, our product that I'm going to talk about, is one of them. Google Container Engine is also based on Kubernetes, so pretty much what you build, you can move them around to Google Container Engine the way around. There is Dice, another container platform, Tectonic from CoreOS, Apprenda, they have it's a PaaS platform, .NET based, and they support Java as well. They announced that they're going to replace their own orchestration with Kubernetes, and this is like a huge and interesting move that we see happening in the industry, that people are replacing the orchestration layer that have built the last 2-3 years and throw that away and bring Kubernetes in, which shows this is a step in the right direction. Apcera, the PaaS from Ericsson, they are doing the same. They just announced that. Kismatic does that, and the Mesosphere also, the data center OS, they are also supporting Kubernetes. So we see more and more traction and more people bringing in Kubernetes and jumping on that movement. Okay, so in that process that I mentioned, I had oversimplified. So look at a couple of more pieces that are actually required to do this. The first one is networking. So I mentioned that each pod gets an IP, and the Kubernetes require pods to be able to talk directly to each other. So somebody got to manage the network. Network doesn't just appear on its own. So you're going to need some software-defined networking attached to Kubernetes to make that platform work. That every time you say create this application, it brings those pods, bring those containers up, and it automatically assigns the IP to each pod that they can talk to each other directly. And there are a set of projects, Flannel, Weave, Open vSwitch, or even like external, like commercial products like Nuage that provide software-defined networking that should be attached into Kubernetes to be able to set up this infrastructure. You would need an image registry also. So I keep talking about Jenkins or Bamboo or TeamCity builds the images for you. But how does this image suddenly get given to the Kubernetes and end up on the host? That happens through the registry. Registry is a repository of the container images that you build. If you're in the Java world, it's like Nexus for jar and var and those kind of things. It's like Yum for RPMs. It's a repo for managing inventorying images. So you would need that. And when Jenkins builds the images, it pushes them to the registry. Kubernetes tell the host that this is the image that you need to run and this many instances of that. So the host is going to pull that image from the registry and would spin it up. So Kubernetes itself doesn't really pull images, but it just tells the host to pull that particular image. There are registries out there also. There is Atomic Registry. There is Docker has its own Docker Trusted Registry. Quay is another enterprise registry. Artifactory in the Java world, they support Docker registries. Nexus, I saw that they are adding in their 3 versions. So there are more and more registries also coming along. So that also you need to stand up near your environment to be able to use this infrastructure. Metrics and logging, that's also not included in Kubernetes. So you got to add Hipster, Kibana, Stack, and those kind of things to be able to monitor what's happening in the environment, to collocate the logs, and so on. When a container dies, you don't want the logs of that application to disappear. You want to go later on and look at that and see what's been going on, right? In an application running for a month, that is not necessarily into specific containers. At any point in time, 2 containers have been running that application, but there might have been 40 different containers. One dies, another one comes up, and you don't want to lose the metrics and logs of a container because it has disappeared now. So you want all that co-located in a central place for analytics. You need more complex deployment scenario to someone to take care of that, right? As a part of DevOps, we do a lot of interesting stuff around deployment. We do blue-green deployments, right? We stand up a complete new environment for the new version. We test that in production, or we in other releases we put some of the traffic on the new release. If everything is fine, then switch to load balancer. Like somebody got to take care of this kind of stuff, and that you don't want to be manual, all right? In the DevOps part, I mentioned that we want everything to be automated. How am I going to do A/B deployment, things like that? So we need complex deployments around that. We could build that through Bash script or in Jenkins or other tools that we need to put into the system as well. Application lifecycle management, somebody to have a view over all this process from the source code, how to build it, then it goes to the staging part, how to tag the images and so on, all the way to production. Application services, that's another part. I mentioned you need database, you need messaging. Just because we're doing container doesn't mean that we're suddenly gonna build application in a different way. We're gonna need the same type of services. We're gonna need caching and so on. So we need to bring these kind of things in also. Gotta figure out which image I should use for MongoDB, which image I should use for Hazelcast. So I gotta go figure all those kind of things out and make it available to my developers. And self-service, right? That's also another part. So we want the developers, the team, to be self-sufficient. They should be able to go themselves and request the environment they want, request the container they want. So I want to put a GUI out there with CLI so people can work themselves. And that's exactly what we have done as a part of the OpenShift project. So OpenShift is a container application platform. It's based on Docker containers, based on Kubernetes, and it brings all those pieces that I mentioned. Put all that together as one integrated platform, that when you stand it up and running, you have everything that you need to build that automated pipeline. There is nothing extra needed to be added to that. It's a true platform for building those containers. So you start off fresh code. You don't even start from container. You want to have my containers? That's fine. You can use that also, the way that Kubernetes does it. But we also extended that in, I have just code. I have PHP code. How am I going to run that in containers? And the platform takes care of building that code, building the container, putting that into the registry, defining the network, creating the pipeline, and deploying that onto infrastructure or chain. So it covers all those boxes that I mentioned. On the bottom, exactly as before, it runs on all the footprints. On my own laptop or on the public cloud or private cloud or virtualization, it doesn't matter. As long as there is Red Hat Enterprise Linux, anywhere that Red Hat Enterprise Linux runs, you can also run OpenShift. And things are scheduled on top of that. There is monitoring solution on the right. There are development tools on the left. It integrates into the Eclipse, for example, directly from the IDE. You can deploy into that from the command line and so on. I'm trying to go faster to show you some of this. And it brings all those blocks. So the key is that what's missing in Kubernetes is a lot of those pieces of infrastructure and developer experience that they have to put around it to build that automation. And that's exactly the OpenShift project intends to do. To bring all of that as a single platform that takes care of this. And bring the self-service, bring the data services, bring the automation, so that you can just describe your application in that YAML file, give that to OpenShift, it build the application, create the image, put it in the registry, distribute it to the host, run it, do the complex deployments, watch the source code if some change happens there. It automatically builds the new container. If you have another container that is based off of this container, it also triggers a build on the other one, automatically tells them that, oh, there's something has changed here, go build that other one. An example of that is one of these bugs that comes out, security vulnerability that suddenly everybody goes nuts about. So you just build a new image of your base Tomcat with that patch, and the platform notifies all the applications that are using this image that, guys, there's a new version of this. Go rebuild with the patch. It automatically rebuilds and redeploy them. So how would the pipeline look like? It completely takes over those pieces of orchestration and management. So we check in source code to source repo, Jenkins pick that change, calls an API call on OpenShift, and OpenShift takes control of the rest. A little more detail, how would it look like for the developer? So we have those steps in a little more detail here, that you have changes in the source code or the configuration in the source repo. The developer check that in. OpenShift pick that up. It looks into the registry, because you don't start from scratch, right? Your application runs on something. Maybe it runs on Ruby or Node.js, so you need some kind of runtime. So the process looks into the registry, takes a base image for that, an image that is certified, application services that comes with the platform, so it's supported MongoDB, supported Ruby, PHP, Java, and so on, that comes with the platform. Images that we have made sure that they don't have any security problem in it and they're in good shape. It takes a base image of that, build your application, add your application on top as a layer, container layer, and saves the resulting image as an immutable image back into the registry. And from that point, based on how your pipeline looks like, it takes the resulting image and deploys it onto the infrastructure. Okay, I have 5 minutes. If you have questions in the meantime, you can ask, but I'm going to at the same time show you as we go. So I go to the console. I have set up this environment on top of Amazon Web Services. So that's another points of OpenShift that are not tied into any particular way of infrastructure. I can, whatever automation I build, I can take it and run it somewhere else on OpenShift or even off OpenShift is something that supports Kubernetes and Docker. I log into the console. I have a list of projects that the admin has given access to me. I go within the project. The project is empty right now. I don't have anything in the project yet. Within each project, there is an admin also that can define who can do what, right? Developers maybe can create projects. You have 2 operation people within the team that they can also remove the containers or they can do monitoring. So you define who can access what, or you just allow everyone to do anything. I say add project. There is a series, there is a list of many of things that I can use. I can myself add stuff to this for my application. I'm going to run a Node.js application. There was a sample here. I have a sample already myself on GitHub. I'm going to use this instead. Copy the URL. This is where my source code lives. I go with default for the rest of the parameters. I can say if I need to use a MongoDB, what's the username, what's the password for that, and create. So this is the simplest way. I'm running with 1 container. I don't have anything about Docker yet. I don't have anything about container. All I have is a source code of my application. And if you look here, there is nothing about OpenShift in this. It's just one Node.js file. The server returns is also a bit slow. And it shows the index HTML that is in the views part. So OpenShift looks at the source code. It realizes that it's a source code. It has to build it. It builds the code. You see there is a build happening, build Node.js example completed. I can look at the log. If you have played with containers, you know that that's another challenge. If the container is happening, you want to go look into the container. Now Docker supports exec and stuff. Before it was a little more difficult. With OpenShift is all integrated into the console, also CLI. I don't have to go into container. If I want to, I can SSH into the container without having SSH running in the container. But for looking at the logs, I just can see it here. There is an npm build happening. And when the build finishes, a resulting image, an image is built for my application, the Node.js example, and is pushed into the registry that is integrated and available in OpenShift. Maybe I should zoom in a little, more visible. Here. After this is successfully finished, we see that that container got deployed onto one pod somewhere on that Amazon infrastructure that I have defined for the platform. It automatically hooks into the load balancer. There's a load balancer comes with the platform. It generates a URL for my application. If I go to this, I see the application is up and running. Right. Which build I have used, what was the git commit that was used for this particular thing, what ports are exposed, and so on and so on. But now let's do the DevOps thing. Let's make a change. So if I go to the build defines how the application, where should the application be built. I get some metrics. I have had 1 successful build so far. And this strategy of build was that build from source code. I might say build from a Docker file, or don't even build, just download a Docker file from Docker image from Docker Hub or some other registry. So you have all combinations of how you want to build or run your containers. I have a GitHub webhook. I'm going to copy this. Go to my GitHub repo, add a webhook. So webhook is a way that GitHub interacts with CI engine. So every time I make a change in my code in GitHub gonna make a call to this URL to notify the system a change has happened, and that receiving system is responsible for doing something against it. And OpenShift integrates into that. So every time I make a change, it exposes URL that GitHub can make a request, and it tells OpenShift code has changed. Go rebuild that application. So let's do exactly that. I'm gonna clone this source code. Okay. Inside the views, I have one index.html. That's the source code of this page that we look at. So let's change a text on this. So this text should be somewhere here. Search for it, there it is. So say welcome to DEVOPS 2016. Made a change. Let's commit that and push it to GitHub. Upload it. If we look at OpenShift, we see a new build is triggered. It's rebuilding the application. You can look at the logs again as it's going forward. You can follow this. So it's a regular NPM build that Node.js applications have. It's going to happen, and when the build finishes, a new version of this application is going to be automatically redeployed and replace this container. And that's also the deployment part that you define in OpenShift. You might choose different strategies. Right now, is just take it down and deploy the new one. If you have 5 of them, you might want to do 0 downtime rolling deployments. You might want to do A/B deployment with Canary or something. And that's also a strategy to define that spec of the application for OpenShift to take care of that. The build is finished. It's bringing down the previous container and deploying the new one. So you see the build 2 is being deployed, and the build 1 going to disappear. So I have the new version of the application here. Welcome to DEVOPS 2016.
Sorry, can you show from where you created this project? Because I tried this last week and I got this old version of OpenShift running from the OpenShift domain, basically. And I couldn't.
Good question. Give me a second to answer that. So, what versions of OpenShift are out there? OpenShift is an open source project called OpenShift Origin on the left side. That's the upstream project. We work all the developments. There are 3 commercial versions of that available. OpenShift Enterprise is the same code base. We push it through quality assurance, certify it, make sure everything works perfectly, and you can run that on your own data center. Or I should say, you can run it on any infrastructure that you yourself choose. You can take it, put it on Amazon, put it on Azure, your laptop, you take care of where you want to put that. There is OpenShift Dedicated, that are dedicated instances on Amazon, dedicated to you. So RedHat takes care of operation of that. You just use the platform, but it's not shared with anyone else. You can put VPN between those instances and your own infrastructure. You're in control, but you don't need to take care of the platform. You just use that. And OpenShift Online is, there's this pass model. You just go drag your credit card, you get a number of containers to run. And the last one is right now in process of going to version 3, the version that I have been talking about. That's what the question is related to. So right now, if you go to OpenShift.com, you go to OpenShift Online, and that is running based on version 2. And in about a month, we're going to have a limited public preview of version 3 running on online. And during the year, that is also going to upgrade to OpenShift 3. And the reason for delay is the scale of operation that we have there. We have more than 2.5 million applications, containers running OpenShift Online. So we can just, like on a day, shut down everything you bring up. We're here in this so that all applications are fine working properly and moving them to OpenShift 3. So if you want to try today OpenShift 3, where you can get this? The first one is on Amazon, OpenShift Test Drive Lab on Amazon Web Services. You go to that URL, you just sign up, it's completely free. You get a complete OpenShift 3 environment for about 8 hours, I think, that you can run labs and try things on it. It's pretty simple, go give it a try. The second thing you can use is an all-in-one box that is the origin version, the upstream, if you want the bleeding edge features of OpenShift. There's a Vagrant box. I don't know if you can read it, the coloring is not that good. You just run Vagrant init, the name of the image, and Vagrant up, you get a complete the community version of OpenShift up and running. And we have a similar thing, container development kit. That one is OpenShift Enterprise 3 that you also can run that on your platform. It's also based on Vagrant. You go to that URL, it has the instructions. That's also completely free. You just sign up, you download this Vagrant image, and you follow the instruction. You get one OpenShift box on your own machine that you can deploy things. Everything that I did, you can just do there and play around with it.
Okay, thank
that
you.
was it. Thank you very
Do we
much.
have any more questions? Maybe we have one really quick one. There you go.
Can you do a short recap about the difference between Docker and Kinetic?
Between Docker and
What was the other one? Kinetic? The other technology?
Kubernetes.
Kubernetes.
Right. So Docker itself is just the API for running and packaging container. It's the packaging format, that binary that I said, and also those commands run and build. Kubernetes builds on top of that to say how to, now you have built your image, and you want to run 20 of them. And you want to run it on top of 10 different hosts. 10 of them are on Amazon, and maybe some of it also on your own infrastructure. It takes care of putting the container in those environments, make sure they're up and running. If some of them dies, it brings them back up. It adds storage to that, it adds a lot of things around that. Right? It solves the problem of, I have a container, I'm going to run a lot of them, and a lot means 5, 10, 20, whatever, on a large number of hosts. How am I going to manage that? And Kubernetes manage that for you.
Quick question still, Rancher vs OpenShift. What is the value of processing for OpenShift?
Once more.
Rancher against OpenShift.
Right. Rancher is also an interesting project. So Rancher has a Rancher OS. It's an operating system, lean operating system, and they add some orchestration on top of that. So Rancher itself, it does similar things to OpenShift, but it doesn't have the same developer experience. Rancher operating system is fairly new, so it's a matter of...
The development is missing from Rancher, yeah, but the deployment thing and...
the deployment it has, and it also supports Kubernetes to my knowledge, so you can use Kubernetes with Rancher or Docker Swarm with Rancher, if I'm not mistaken. That's how, but they look a lot on the operation side of this. They assume that you have the images, you know how to do the automation, and you tell the Rancher to run this. All right, so they try to do that part of this, and it's a bit of a history thing also. It's a quite new operating system around the corner if you dare to run your stuff on that, your banking system, for example.
Yeah, I'm looking for not for the OS, but the Rancher.
Right, but it is an interesting project, so there are a lot of different solutions coming around the orchestration, absolutely. And I'm going to be around here, so if you have more questions, come talk to me and we'll chat. Thank you.
Great, thank you, Siamak.